Thanks. Yeah, thanks. Hello, everyone. I'd like to introduce myself first, and then before I don't want to get you guys bored. I know this is the last session for the 3 days. I'm supposed to join in person, but I could not join. I missed this opportunity this time. Yeah, myself, Naresh Ravuri, Senior Manager Engineering Software at Magna Electronics. I'm working on this Linux and other topics almost like a few years now on the ADAS, especially on the ADAS. So last time in the workshop, I kind of presented some of the topics on the how we are trying to achieve the safety with the Linux. I will try to kind of make it a quick recap and also try to address some of the other topics, not just on the safety aspect of the Linux, but what are the challenges that we are having to adopt the Linux into the ADAS ECUs and options we have. Yeah, here is the agenda. And most probably I would not take not more than 15-20 minutes of your time, everyone's time. Recap from the last workshop quickly and the challenges with the Linux in the adapting in the ADAS. ADAS is like advanced driver assistance systems. I mean, some of the space folks, I mean, who doesn't know about ADAS, I'm just trying to give, this is a kind of safety critical ECU within the vehicle. And other topic which I will be covering quickly is optimization techniques for the ADAS applications. So let's say when we are trying to consider Linux for the ADAS applications, what are the techniques that we generally can consider? And also the next, another quick topic which I would like to kind of cover is on the containers. How exactly that the containers or process will help in the making the edge ECUs. Okay. A quick recap from the last workshop. Last workshop, we discussed about the safety goal, how this overall system needs to be decomposed into into the safety case and decomposing the architecture elements, and as well as putting this architecture in the context of operating system and identifying the failures and how these failures need to be detected. By getting into the safety case and overall safety goal meeting, we think that, okay, ADAS, sorry, Linux can be adapted into the automotive safety applications, which we deep dived into the last time. What are the things that needs to be done? I'm not covering that. Like we are by doing memory protection, by splitting the QM and SL process, and hardware supported MMU and other protection mechanisms. Now jumping onto this today's topic, why Linux is not a popular in safety applications. It need not to be in ADAS applications, but any other safety applications within automotive domain, ADAS and other ECUs. I mean, of course, it's kind of popular in the infotainment and other aspects, but not in the safety. This is not nothing to do with the safety, I would say, but there are some other challenges Linux comes with before getting into the safety. I mean, last time we discussed about safety, but rather than looking at the Linux as a safety issue itself, there are many other things that needs to be addressed before getting into the safety. Those are like these are the major challenges, at least we have seen in the practical, in real-time scenarios, what we when we are trying to implement. Non-availability of ADAS specific operating system. Okay, I mean, this need not to be ADAS, but safety specific, safety critical Linux operating system is not available in the market at this point of time. There is a AGL, I mean, which is automotive grade Linux is available, but this has a lot of things that needs to be still optimized to get to the safety operating system, safety critical ECUs, or maybe time critical ECUs. And another next is the size of the Linux or file system. The size of the Linux system, I mean, you can get to the kernel itself, it can be tiny, but whereas when you mount the file system and BSPs and everything, the size of the system itself is becoming huge. When it comes to the safety critical ECUs, the size matters. At the same time, not only the size, the availability, how long and how quick that system can be available once after power on. That is nothing but operational availability of the Linux operating system. This is the major, when we compare size versus operational availability. Operational availability is the major critical topic or to major critical item than the size. And another is the real time. How do we get to the real time behavior of the Linux? As long as if we can solve these problems, I mean, in the first step before getting into safety, the adoption of the Linux operating system itself is the kind of, I would say, smooth road, but at least majorly accepted mechanisms. And considering these challenges, I mean, how do we, but is this a roadblocker? I mean, definitely not, but there are options available to overcome these challenges. That, I mean, for the first one, non-availability of ADAS specific safety specific operating system, which we don't have, but there are many companies, many organizations are doing themselves, including maybe Red Hat or the EB and some other organizations with the help of ELISA organization. And when it comes to the other parts, like especially the size and the file systems and operation availability, there are some techniques which we could follow and which we are following as well. That these are nothing new, but when it comes to the safety critical ECUs, the optimizing the startup scripts, which is mandatory. That, I mean, when we take generic Linux operating system, even AGL, I mean, it's a matter of AGL or any other operating available Linux operating system, they are not optimized for the intended use case. Those need to be optimized first, so that at least we'll have a startup time reduced. And when we look at previous slide, when we talked about size versus operational availability, in the ADAS applications, I mean, at least size we can accommodate by increasing the flash chip, which is the size is not a problem. But when it comes to the operational availability, is the biggest challenge. Let's say, for example, in ADAS applications, in most of the, I mean, in terms of MCU, like MCU means safety critical micro, that has to be operational within 200 milliseconds, which is not possible at this point of time with Linux. But still, when it comes to the ADAS applications, like application environment, that needs to be at least available within 4 seconds. Or, I mean, most of, let's say, if you take any surround view cameras or any cameras, those need to be operatable within 4 seconds in general. Okay. In general, are fully operational once after power on. For that biggest challenge, what we have seen is once we power on, the file mounting and Linux, the time it takes to copy we boot from, generally we boot from the flash, I mean, flash copies to the RAM, and that itself will take time, and that's a compressed image, and decompression of that image itself, takes a lot of time. That's the one challenge that needs to be resolved. On top of that, the default Linux operating systems comes with the whole set of modules, which we don't need it for our intended use case. Like especially in this case, an ADAS is an example. When you look at Linux operating system, that comes with the Bluetooth, that comes with network drivers, that comes with keyboard and output devices, and many other modules which are not required for the safety critical issues. Those need to be removed first, and those are the things that will save a lot of memory, at the same time mounting time. And also that not only these removing, I did not list all of the modules, but I listed a few of the modules that needs to be taken care, at least on the high level. And other part is that U-boot. I mean, Linux comes with U-boot, whereas U-boot is not a mandatory in terms of ADAS applications, because of ADAS are safety critical applications. Most of the applications in the term will have MCU, like microcontroller unit, which handles the bootloader part, which eliminates the U-boot necessity. We still need to have some of the mechanisms within the U-boot, but not complete U-boot. That saves a lot of power up timing in terms of power up, and at the same time, compression logics, like we compress the complete image and store it in the flash. When we are trying to power on, it uncompresses and stores it in the RAM. When you just looked at the size versus speed, with the speed is the one like which is the most critical, the operational availability. When it comes to that, the compression decompression algorithms, choosing the right decompression algorithm is the key. When it comes to the size versus speed, that saves itself is the operational time in terms of milliseconds and seconds. And at the same time, And other topic that is parallelization. Like during initialization, we can automate or we can parallelize some of the items like the uncompression items, the decompression items can be done separately in the separate thread and separate process. With these mechanisms, I mean, we can prioritize these speed versus size, and also we can get to the challenge by we can overcome the operational availability of challenge. As long as once we can overcome this operational availability challenge, then we have the use case for the usage of the Linux in the safety. I mean, I would not say safety issues, but at least on the other than infotainment issues, there are many other issues that can be adopted Linux operating system by adopting these mechanisms. Yeah, I mean, that's with respect to the optimization techniques that which we could do for the major adoption of the Linux. And other topic this which I want to kind of touch a little bit about is the containers. I mean, now containers kind of getting popularized within even on the no, I mean, containers are very popular in the server world. I mean, Linux is containers is nothing new for the Linux in the automotive, but it's new to the automotive itself. When it comes to the containers, how do we containerize the application so that the process or modules feels itself its own entity and it has everything it's required for that purpose of the application. And of course, I mean, when you kind of look at container is not as a virtual machine, but we have to look at container itself is a process that where we can combine multiple modules into containers, and so that it will have its own memory, and so that we can replace the container and deploy the containers within the edge also. I mean, as similar to the servers, like if you can get to that containers within the edge ECU, that will have a lot of use cases within the edge ECUs. Yeah, as I said, I mean, it's the same statement, not same as VMs, rather than like process. Like build once and deploy anywhere, like my namespace, make containers feels like it has a separate mission, which is something not new. And containers brings more isolation between SL and the QM component, like safety components versus non-safety components. We can make this as two different containers where we'll have a lot of restrictions between the containers, which is same as like process, which way that it's kind of expanding the process, and by adding the containers, more isolation between the SL and QM components. Okay. Yeah, I think that's all I have for today. Yeah, any questions or anything?
Are there any questions?
Yeah, better question.
Yeah.
You can hear us.
Yeah, he can hear you.
Okay, cool.
That's
Okay.
Yeah.
Great. Thank you. I was wondering in your experience whether the adoption of standards should.
You need to come closer and
Yeah.
project.
Closer.
That's what.
There was a
I'm trying to hear.
Well, for a reason.
Okay. Can you hear me okay now?
Yes. Now I can hear you. Okay.
Very loud. Everyone in my life says I'm too loud, so this is the first time. I'm wondering in your experience, whether the adoption in automotive of standards like OSEC and AutoSAR, how that plays into the reluctance, impedes the progress of Linux in systems that touch safety like ADAS.
Okay. I mean,
Is that an impediment for either a technical or maybe not even a technical one, but sort of cultural, and what happens from SoC manufacturers who are embracing those standards and continue to?
yeah, I mean, when we look at OSEC versus Linux, I mean, Linux operates in the SoC world, whereas OSEC mostly operates on the MCU world. It's kind of mindset shift. I mean, at this point of time, automotive itself, I mean, I would not say complete automotive. In the ADAS itself, okay, kind of changing from MCU world to the mostly into the SoC world, right? I mean, if you look at if you look at any ADAS application previously that which were running on MCUs are now running on the SoC or SoCs, major SoCs starting from TI, NVIDIA, or any SoC if you take, including Qualcomm or any other SoCs. Most of the operating systems, either Linux or QNX. I mean, it's not a OSEC operating system. OSEC operating system is still applicable only for the MCUs, right?
Thank
Did
you.
I answer your question? I'm not sure. I just want to make sure.
Yeah, I probably should have added the adaptive AutoSAR.
Oh yeah. Okay.
Part two, since that is bleeding the distinction between those two worlds, I think.
Agree. I
Right.
mean, adaptive AutoSAR makes more sense in terms of Linux. I mean, than OSEC. Yes, I mean, with that, yes, adaptive AutoSAR still needs a traction. A lot of traction is required because I mean, I don't. I mean, this is not an AutoSAR forum, but I don't want to comment on AutoSAR how exactly that's getting traction. But whereas, I mean, as long as I mean, if you have operating system, yes, I mean, adaptive AutoSAR, it doesn't matter either. It can be adaptive AutoSAR or maybe some other third-party middleware. There are multiple middlewares available in the market along same as adaptive AutoSAR. What they're looking at is POSIX-based operating system. Okay, either that can be Linux or that can be QNX or that can be something else. But Linux is the most prominent POSIX-based operating system, which can be supported on the adaptive AutoSAR or some other middlewares, or which are operating on the ROS-based middlewares.
Yeah. Thank you.
I mean,
Thank you.
what can be added on this is that for the adaptive stack, for example, the reference implementation or base implementation of running Linux, and also the pre-development is actually done in the Linux space. So there is a bunch of other systems which run Linux during development. But as there is no safety certification on the Linux system, and it takes efforts to get the safety certified, that's why there is a shift to certified effort than for the production, which gives you an effort lived in the way how you're doing it. And this is mainly true for, I would say, Western worlds, because there are, we saw it in another presentation, we have new players, right? We have like Tesla, which is also Western world, but more like the aggressive one in there, using Linux in safety critical application. And here you can see from the automotive industry, they're not really our traditional automotive, right? They are not so much into AutoSAR, they're not so much into OSEC, and they are not in an environment where they were used to build everything from scratch on their own or have 100% supplier contracts. And that's what we see changing now with exactly what Naresh said, with microcontroller, microprocessor moves, seeing you are forced into monopolies of vendors which you want to break up. There you see, like, then you have regional sanctions where you are not able to provide a solution to all worldwide anymore, and that's where open source always pops up more and more. And the main reason not to add it in products often really is just it's made a huge step to have the certification part. And especially China, for example, there are a huge set of other systems on the road which run this. I think 80%, don't get me on the number because I don't have evidence that it's unreal. It's just whatever, it's like 80% of level 2 honor systems run Linux in China. For example.
And they use
Yeah.
Linux.
Can I make comment?
Yeah, no, make comment.
Yeah, okay. I mean, yeah, I agree on the with respect to the safety aspects. I mean, but beyond safety itself, I mean, there are many QM ECUs. They are also still not adopted the Linux. They are also with the I mean, different operating systems. I mean, because of the operational availability challenges. I mean, I agree that safety is the one topic, but to major adoption of the Linux itself is not just limited by safety, but there are many other QM. QM means like quality, which doesn't need any SL or any safety. Safety ratings are low. Even those, I have seen that the different operating, I don't want to name them, but other than Linux, they have been chosen the different operating system because of the operational availability as well. Thank you. That's
There
But
Good. I was going to say there's a comment or maybe question from Patrick on Zoom. Patrick, you want to unmute yourself and
Yeah, I can try. Can you hear me?
yes.
Great. So yesterday we had this presentation from Red Hat with the Red Hat and Vehicle OS, and some challenges you mentioned here, I think were directly addressed by the yesterday with some solutions they're working on. Did you see the presentation from yesterday?
Sorry, it was question to me? Yeah, no,
Yeah.
I did not. Yeah, I'm aware of the Red Hat is also working on it, and also that EB also working on this, trying to make it available. Yes, once they are available, that might be more popular item. Even I know that Canonical and EB are working, and Red Hat is working. Yeah, that will be a big step leap forward once they are available.
The container solution is already available. I mean, the stream, the Java container project. So if you want to play with it.
Oh, we're not function safety.
No, function, no. No, function safety point of view, no, but function it is.
and also I mean, the constraints which you see in which I'm pretty sure, I can just call from my experience, but like the size reduction, the things which we're doing. I was personally involved in 2012 in a triple core ARM system, which had 400 megahertz each, with double core. Then at the end, where we run Linux, and it was sharing the memory. The third core was an RTOS still for a lot of functionality. We had 2 seconds boot time requirements, and we basically run through all these steps. Like the first thing, we came from like 10 seconds boot down to 4 by just switching off that we don't need a CUPS printing system within the car, and we don't want USB game controllers in. Like throwing all the things out, you don't need to get down, and then later on you need to do like compression. We throw away we don't need it for it because we have a dedicated use case. We had no update possibilities at this time and no need for it. So you can throw out further things. We're just getting more challenging use cases. And over the time, it's getting harder and harder to keep these constraints which you have in these systems. And mainly we took a bunch of products from commercial RTOS or whatever we're using into Linux because we have such volumes that we say, okay, just from the royalties you would pay from the artist, you can afford this. And to give you numbers, like, I guess, Naresh, you're also in this, you have products from Magna for driver monitoring, we have driver interior monitoring, these kind of things.
Yes.
And this, like, camera system gets into every car. And it's typically it's like nothing differentiating. You don't buy for this camera thing or so, you just need this part and it has computation performance. So you easily end up like with 10 million pieces for one OEM. And if you have 10 million pieces, you can invest a lot and you don't want to spend this giving it to a proprietary arms royalty part, and you're in QM space still often. And this makes life very attractive to use Linux and also for instrument clusters, IVI systems. Now it's Android because that's even more convenient for the driver, but there the experience makes a difference. We can argue it's really like this, but that's just what we see. So a lot of these things are having been tackled in automotive industry. And I guess that's also what Naresh wants to tell. This is just not visible to the outside because, well, if I make X and I have my 3 megabit UART, it's not the easiest thing to get this upstream. And how I handle my 16 channel audio is to have all the speakers aligned. It's also maybe something which I don't spend the time upstream because very special, unique use case for me. Or we're at Tim's side, like what is my part and isn't really serving the wider community. And that's what automotive does.
Just to dovetail on that, talking about minimal Linux implementations with very, very short boot times. That is a problem I've seen from, I don't want to say my colleagues, but just people I've run into. Definitely not people in this room. I'm sure everybody here can figure out how to make a Linux kernel boot in half a second. But I hadn't myself seen any tooling out there that, for example, keeps track of all of the required kernel config for, say, a minimal system. Sure, you can start at the absolute bare minimal kernel that could boot, and then you just start ticking on. Okay, let's try this config. We'll see if it has boot with this config, and then let's just keep ticking them on. And that's not, in my opinion, not a very good way to approach that. And in build systems like Yocto, Build Root, Red Hat packages, a bunch of packages, they keep track of dependencies, like what software dependencies do you have? I haven't seen anything in the industry that keeps track of, well, kernel dependencies you have. Often that's just scattered somewhere in a wiki randomly that won't come up within the first 10 pages of the Google search. So
So you're talking about minimum config,
yeah, minimum config. Help me make
K-test.
K-test.
It has a make min config.
Okay,
It's, if you go automate boot process, it'll actually do like bisect and remove things until you have a config that's, it automatically does. I run this on my test machines. It gives me a nice little min config that's barely. And you can add options. You can put in you can make a test. You can even add a test to say it has to have network. So like sometimes I'll say ping has to work, you
okay,
know, or something like that.
right.
But it will actually test if it fails it. So you need to be able to automate rebooting if it fails, it goes back to a good kernel and then, yeah.
K-test does config bisecting. I think it's the
Yeah,
only
just-
thing that does. Now,
What?
I thought kernel CI would do config bisecting, but they don't.
Yeah, well, K-test does it. I use it all the
Like
time.
I said, I think K-test is the only thing that does config bisecting. Now, does that apply to embedded hardware? Can we run?
I did this on a snowball board.
Okay. Let's just pick that one. Is it approachable for the okay, let's define the average kernel compiler. So somebody who might not be familiar with kernel development, they're just using build or reactive.
There's a video out where I gave a 2-hour tutorial or something on K-tests, which I show how to build it from scratch.
Okay, well, maybe this could be a focus to address some of these.
And also, another, just one of the things is tracing, and also you could trace the net calls, so you can see every single net call that gets called. And if there's something that's being called, I don't need this, you can disable it too.
Well, okay, so this is a boot time and
Wow.
so
And
I can't
another is
not,
LTTNG. I mean,
but
you can integrate LTTNG to get more traces, and there are third-party
LTTNG.
tools to visualize.
yeah.
Yeah.
So we're actively working on modifying the init call tracer right now. Not init call debug, not the ftrace one.
Well, that trace one's a little bit lower overhead.
Yes, it is. More on that later. But no, but okay, so there's an issue with this type of problem. Which is, I think, characteristic of embedded issues in general. That boot time is a systemic issue, right? You have to, it's death by 1,000 cuts if you try to solve it, right? And so, and which 1,000 cuts you want to make depends on your use case. And so you can't, it's very, very difficult to get stuff upstream that solves it in a general way. And so the way we're starting to try and tackle it is with automation. Very similar to what you're just describing, come up with ways to say, well, look, if you need networking, then you got to keep this code turned on. But our goal, at least my goal, is to by next summer, have a tool that will actually turn on the instrumentation to measure boot time, and then look at the instrumentation and tell you the configs you can turn off, the kernel command line options you can use that will trim it
further.
down for your use case. That's the goal.
Yeah.
The other
That's
thing-
one of the major things that the SIG is working
Yeah,
on, so.
The Linux kernel features group is mostly about trying to do analysis of features and what the impacts are from a safety perspective. And so they're meeting regularly. Boeing's leading that off, and Boeing is opening up their minimal config.
Right. Pardon me, can you tell me what group?
Uh,
The Linux feature there is only from the US right now, so we're something, so
Yeah.
you start looking into very minimal.
Yeah.
Yeah.
Big.
And so Alessandra here is one to talk to about some of that. But yeah, they're looking at the minimal configs and then the impact of features. So what features are you turning on? What does it have? What happens with it? Things like that. And trying to improve, quite frankly, the documentation upstream, please, of some of this stuff, as well as help us come up with a reference config for these sorts of applications. And so Boeing is very active in this space as well, and so there's collaboration potential there.
And also be careful of like the device tree and ACPI, because we actually we debugged something where we, like, the system stopped for half a second, like, what the hell was going on? And found out that the, our touchpad had something, the ACPI table said, sleep for a half a second. It said nothing to the kernel. It was the ACPI table said, tell the system to sleep, and that's what it did. It slept for a half a second.
Yeah.
Could say, there's lots of paths you have. For instance, I'm tiring the random events. Well, one Unix is that. So that, oftentimes embedded systems are running on nothing but random tests.
There's one more.
So there's one more question or comment. Hosea, do you want to come off mute and ask your question? And maybe we can wrap up this session, let people go on break.
Yeah, sorry about that. I stepped away for just a second. Yeah, so we do a lot of work with embedded systems in general on vehicles, and obviously boot time and image sizes are always an issue. I'm curious about what kind of size range you're kind of looking for in a full OS image that you think would garner better adoption in the automotive industry.
OS image itself is pretty small, right? Kernel itself in general, but when you look at complete image or an application, we are looking at less than 1 MB. I mean, when I say complete application, that has not only just operating system. I don't have statistics of the file mounting, but generally we prefer like tiny FS than the full size mounting. We generally go with tiny FS file mounting system, but I don't have exact numbers. But kernel itself, I mean, no concerns in general because kernel is pretty small. But when it comes to the modules, that depends on use case.
I would say the answer is depending on what your chipset has and where you get the best price for the chipset and memory. We were doing a lot of, I remember a case where we're doing optimizations on which RAM footprint we have, and then we figured out that we don't get we could get the round chipset, but if we take double the size of RAM, it's getting us cheaper than the half size RAM, and suddenly all our RAM problems were resolved. And if you don't get a certain piece in automotive quality and you want automotive quality for your use case, you just check like, what is the cheapest thing which I can have in my phone and adopt a system for it. And the more constrained and the more small you do this now for SDV defined things, like we have software defined vehicle. And if you continue the automotive paradigm to make it as small as possible in your constrained hardware as you can, well, then you don't get the update in anymore, and there is no gzip space available for anymore for solving problems which you are not thinking about with maybe security or whatever other issues. So I think that's a paradigm shift which we need. It's completely true. That's driven by this, but it cannot last like this over the longer time.
Okay. You good with that, Dale?
Yeah, I think that's good.
Well, then, I think then we will go on break and we'll resume at the 11:30 and we'll do our wrap up with the workshop.